Okay, everyone, I think it's time. Let's get going. So it's good to see so many of you joining me. We're near the end, just 2 sessions left. Hopefully we'll have a bit of fun today, a little bit of SQL magic. So for those of you who don't know who I am, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team, and it's our job to help you get the best out of the Oracle database, so work more effectively with it. So I've got a number of ways of doing that. You can reach out to me through Twitter. Got my Twitter channels there, my blog, and my YouTube channel. Or if you've got problems with Oracle, things you don't understand, need help, you can contact us on our official channel. So this is Ask Tom. Many of you will be familiar with this. Tom Kite used to run this single-handedly. 6 months ago, he decided to take a break, sabbatical, so myself and Connor are now taking over and answering questions on Ask Tom. So if you've got problems, you want to understand how to run a piece of SQL, understand more about database, how it works, feel free to ask us here. Please reach out. We're here to help you. But I don't just want to know about how you struggle to actually use the syntax. I want to know from you how we can make the database easier to use, what we can do to make you more productive and work more effectively when using the Oracle database. So if you've got problems about SQL, the Oracle database, PL SQL, ask here. You've got general feedback, then feel free to reach out to me via email or Twitter, and I'll do what I can. So I do work for Oracle now, so you can't believe anything I say, but seriously, I'm not really talking about futures today, so this doesn't really matter. What I'm doing instead is showing some SQL magic, so something a little bit different. And to start with, what I'm going to do is a SQL take on the classic cups and balls trick. So I'm just going to create 3 tables here. So a red cup, a green cup, and a blue cup. And I'm going to insert into these cups different color balls. Now the balls, or the rows, have an affinity to the cup of the same color. So they like to go into the cup of the same color. But before I begin, just to show there's nothing up my sleeve, so they're currently all 3 tables are empty, no rows in any of them, and there's no triggers on these tables, so nothing up my sleeve here. So just to start off with, we insert the blue ball into the blue cup, and there it is, the blue ball's in the blue cup. Take a look, put the red ball in the red cup, and the red ball's in the red cup. Put the green ball in the green cup, and green ball's in the green cup. So nothing up my sleeve. You're probably going, well, yeah, okay. SQL 101, you all know this. You all know this. So let's take it up a notch. I'll delete everything out of those tables. There we go, all gone. And this time I'm going to put the red ball into the green cup. So the red ball goes into the green cup. We take a look in the green cup, and what do we find? It's empty. Where's the ball gone? Well, it's jumped over to the red cup. There we go. The red ball is in the red cup. So now I'm going to put the blue ball into the red cup. Put that in, and what do we find? Well, there's still just the red ball in the red cup. Where's the blue ball gone? It has also jumped over to the blue cup. There we go. So, now, some of you enjoying that? Good. So let's start again. Let's delete them all out again. So they're all empty again. Now, I'm going to put the green and blue balls into the blue cup. In they go. Green and blue in, 2 rows inserted. Where are they? Well, the blue ball stays in the blue cup. That's where it likes to go. Red cup is empty. There's no red balls I've inserted. Take a look in the green cup, and we find there's the green ball. So let's take the green ball out of the green cup and put the blue and red balls in the green cup. There we go. 2 rows inserted. Anything in the green cup? Well, of course not. Those balls don't like to go there. The red ball has jumped all the way over to the red cup, and the blue ball has jumped all the way over to the blue cup. So we've now got 2 blue balls in the blue cup. Okay, everyone with this? Following? Let's start again. Delete, delete, delete. Empty them all out. Now, I said that the balls have an affinity to the cup of the same color, so they like to go into the cup with the matching color. But the red cup's special. Oracle is the red company. It's our color after all. So what happens when we put the red, green, and blue balls into the red cup? Well, let's take a look. In they go, 3 rows inserted. We find there's nothing in the blue cup, and there's nothing in the green cup. But if we take a look in the red cup, we find all the colours of the rainbow. So this is all a bit fun here. But I'm sure you've guessed it's not magic really. Has anyone got any ideas what's happened? Anyone want to guess how I've done this? One other guy? No, there's not exactly. Any other ideas? Any other thoughts? The leading was a bit shady. No. Views, yes, thank you. Someone's got it. So if we bring up the connections and take a look at the tables, when I said these were tables, there isn't tables at all. There's only one table there, the cups table. So as someone shouted out, the three colored tables are in fact views. So we'll see we've got a red, green, and blue cup in them. So just before I go on, actually, I'll just clear the blue and green ones down, make a bit more space. There we go. We can see what's going on a bit better. And if I bring up the blue cup view, we'll see in the definition of it, there's a where clause which says only return rows where the text contains blue. So if I go to the SQL, when that comes up, you'll see there's a where clause checking whether it's blue. So that means it will only return rows from the cups table that have the text blue in them. But the trick I just showed reveals an interesting quirk about views, and that's you can insert rows into them that you can't query back out. Now, kind of makes for a kind of neat magic trick, but who wants that magic in their real applications? Probably none of you. You know, this is the kind of thing which can easily lead to a lot of confusion. I think views have a lot of power. You can use them to do things like implement security. So your application, rather than connecting to the view, connecting to the table, connects to the view, and you have a where clause on there, so people can only see sales for their region, only certain people can see invoices, that kind of thing. But this is a bit troubling. If you've got data you can insert but not query back out, you can end up with bizarre situations where you've got users desperately typing in all their information, submitting and going, I can't query it back out again, what's going on? And very strange situations, and it can suck up a lot of cycles investigating to find there isn't a problem really, the data's still there, they've just created the same order 50 times. It's that they can't query it back out, which isn't very nice. So at this point, you might kind of say, well, does that make views kind of useless? Well, no. So I'll just reset everything back before we go on. There's a little known feature for views, and that's this with check option. So you can't define constraints directly on views, but you can use this with check option. So if I do that, this means that Oracle will now verify that the data you're inserting actually matches the where clause for the view. So we've got that, we've got the with check option on that view. So we can insert a row that says blue, insert some gibberish which also has blue in it. So these are going into the view, select, and we can query them back out, that's all fine. And they're in the base table, the cups table. But what happens when we try and insert this green ball, when we try and put that in? Well, instead of it just vanishing on us mysteriously, we get a nice little exception here, with check option where clause violation. So Oracle said, hang on a minute, you're trying to put something in there which you can't query back out, which is kind of neat. So kind of gets around this problem of the vanishing data. And all you got to do is add this with check option. Just to verify, you see in the cups table, there's just those 2 rows I put before. The green one isn't there. If I recreate it without the check option and try and put the green ball back in again, we find it goes in nice and easily. So that's the situation we had to begin with. We can't query it back out, but it is in the base table. So not great. So this applies not just to inserts, it also applies to delete updates. kind of deletes, but I can't really think of a situation where you delete something that you're deleting it anyway. But anyway, so we check it, recreate it with the check option, and we try and update the rows that are already in the table via the view to be green. Whoop, and skip through my things, which is not what I wanted to do. Update that, and we'll see we get the exception again. View with check option where cause a violation. So I think this is a really cool tool. And if you're creating views that have where clauses and you're going to do DML against them, so inserts or updates against the view itself, I'd really recommend doing this. It can save yourself potentially a lot of pain in the future. You'll get these exceptions rather than vanishing information. So this is all very well and good. I've answered half the question. We saw that's how I got the balls to move around in the different tables or views. Where did all those different colored balls come from? Any ideas? Any thoughts? No? Let's just, okay. So, was that? Someone said something there? No, not exactly. So here's the setup script I used to create the table. So when I created it, here's the cups table. And then I inserted all the different colors. So all the things we saw at the end, and saved it. And at that point, I created a materialized view on the table, which is just a select star from it. So if I rerun that now, let's just execute that again. So at this point, we've got a table with all the different colored balls in them, and a materialized view, which also has that information in. So what's the use of a materialized view? Well, when you've got a materialized view, Oracle can do what's called a query rewrite. So instead of executing your query, it can substitute in a materialized view which has the same text as your query, or equivalent text. So at this point, we query the table, we've got the different colored balls, query the materialized view, there they all are. But when we run the query against the cups table, so I'll get the execution plan, and hopefully you'll see that rather than querying the table itself, is what it's done. Oh, it's not worked properly for some reason. Oh, it's because I've not committed probably. It's always annoying when things don't quite work how you expect. But what Oracle can do is a query rewrite. So if you've got a query that has text that matches your materialized view, it can substitute that in. But it can only do this if the data in the materialized view matches the data in the base table. So if I delete the cups table, wipe that out, we'll see the materialized view still has all those different colored balls. But the cups table itself is empty. So how did I get it to actually use the materialized view? Well, when I said there was no triggers on those tables, I kind of lied. There was a trigger on the cups table itself. And if we scroll down a bit further down, you can see there's a compound trigger. And what that's doing is counting how many rows I inserted into the table. So you just got this simple counter. After each row, increment the number of inserts. And when I've inserted 3 or more rows, we got this slightly strange looking statement here. Alter session, set query rewrite integrity equal to stale tolerated. Stale tolerated, what does that mean? Well, when you, as I said, Oracle can use materialized view to substitute in, rather than executing your query, it can substitute in the materialized view itself. However, you'd only want to do this normally if the materialized view, the information in there, matches the information that's in those tables exactly. Otherwise, you get a situation where you've got, again, another dodgy kind of magic, wrong information. You're returning a query, your query is returning something which doesn't actually match what's in those base tables. And by default, Oracle runs under the integrity mode enforced. So that means the information in the base tables has to match what's in that materialized view. I've just realized what did before. So when it's enforced, it doesn't use the materialized view. But if I set it to stale tolerated, like so, we query the cups table, we get all the different colored balls. That's because Oracle substituted in materialized view. So if we look at the execution plan, we will see that when it comes up, it will say materialized view rewrite. There we go. Materialized view root rewrite cups MV. So this is kind of interesting and again makes for a neat magic trick. But again, why would you use this feature? What's going on here? Well, let's take a little step back a bit. For a materialized view, for the information in the materialized view to match what's in those base tables, every time you commit a change to those tables, so any transactions which insert, update, or delete, the rows in those base tables need to refresh the materialized view. So what does this mean? It means every time you're committing a transaction involving those tables, so anytime I commit a change to the cups table, to keep that materialized view in sync, we've got to refresh it. We've got to set it to be fast refreshable on commit. However, this is obviously going to add a little bit of load to your database. So there's going to be a little bit of extra overhead every time you commit a change. Now, for simple materialized views, this may not be noticeable. Hopefully, in many cases, this is going to be kind of small and you might get away with it. But if your database is really busy and you're already close to, your CPU threshold, this might be enough to tip you over. And there's a bigger problem with these materialized view refreshes. Only one process at a time can refresh a given materialized view. So you've got 10 people, they're all inserting different colored rows into those cups table. They've got to line up in order. So you've got your 10 people, insert rows, all hit commit at the same time. They've all got to line up and wait their turn to refresh the materialized view. So while the overhead for each individual transaction is small, just the fact that you've serialized, that everyone's waiting, can be enough to create a serious bottleneck in your application if you've got a lot of concurrent, a lot of multiple people running transactions on those tables at the same time. So this can, as I say, be a really big overhead. So making a materialized view fast refreshable might cause you performance problems. And some queries you can't make materialized fast refreshable materialized views for. We get better with each new version, the restrictions lessen, but if you've got one of these really complicated union, group by, sort, aggregate, outer join queries, there's a good chance that you can't set the materialized view to be fast refreshable on commit. So what does this mean? It means there's always going to be a period of time where the data in the tables doesn't match the data in the materialized view. So you can never get this query rewrite. So what's so great about query rewrite? Well, in this situation, again, it's a little bit Mickey Mouse. I've just got like a 10-row table. Let's imagine that there's a billion rows in this cups table. And all I want to do is count how many rows there are of each color. Now, if there's only 10 or so different colors, that's a 10-row result set. But full scanning a billion rows, that's going to take a little while. Several seconds, several minutes, possibly longer, depending on your setup. But if you've got a materialized view, which has aggregated that, so calculated it and stored it down into 10 rows, querying that is like nothing. It'll take no time whatsoever. So materialized view query rewrites are really, really helpful when you're aggregating huge data sets down into small sets of rows. So counting how many orders there were each day. What's the total volume of sales we made yesterday? That kind of thing. So where does stale tolerated come in? Well, if your table is insert only, so you only ever add information, you never update or delete it, you know all the information in the history is correct. You're not going to change it. But Oracle still won't do a query rewrite automatically for any of your queries because there's new information added. But last week's information is all perfectly fine. You could use the materialized view for that. You'd kind of like it, actually, because that's going to be nice and quick. But full scanning your many billion row table is going to take minutes, maybe hours. In this case, you can relax it slightly and say, well, I know, trust me, Oracle, I know my data. I know that for the data I'm looking at, it doesn't matter. I'm happy that it may be slightly out of date. So this is something where you take the onus, you say, I'm going to override you, Oracle, and do something a bit different. So we saw that. So that was the cups and balls trick. We saw I had 3 different colored views and with where clauses in them. And those where clauses meant we could insert rows we couldn't query back out again. To prevent this, just add the with check option to your views and you get an exception rather than disappearing rows. To make those different colored balls at the end, I just had a simple trigger which counted how many rows we were inserting when it passed 3 or more, set the session query rewrite integrity to stale tolerated so it could use that information I'd saved in the materialized view previously and substitute that in. So that's the first trick over. For the next up, I'm going to do a card trick, and I'm going to need a volunteer for this. So there's a teddy bear and a t-shirt for anyone who wants to come up and volunteer. Someone come up, please. Yeah, come on, up you come. Thank you, everyone. Give them a round of applause. Okay, so come close. So what's your name? Giannis. Okay, can you spell that, please?
Janis.
Janis, that's right, yeah. Okay, so what I'm going to do in a second is ask you to choose a card. So I've got, let's create the table to start with. Helps if I do that. So I've got a deck of cards here. Okay, so you could, oh no, my connection's gone. This as well, this happened now rather than in a couple of seconds. Sorry about this. There we go. Let's just reset. Reconnect, yes. Never, you can't see things when you're... Okay. So, and in a second it will come back, and I've got a deck of cards, which is a table which just holds all the different colored, cards. Okay, so, we need to recreate it. Didn't quite get that far. So we'll create the table, and in a second. No errors, there we go. So here we go, we've got a deck of cards, so all the different cards, you can see 52 of them. And what I'm going to do is ask you to choose a card. And the way you'll do that is by, if you look at here, so you choose the value, just copy and paste it in there. So if you wanted the 5, you'd copy 5, paste it there. 5 of spades, copy spades, paste it there. Okay? You happy know what you're doing? Okay, so once you've done that, so copy paste the values you want in, and then just hit the green button to run the statement, to update the cards. Okay? You got that? All right then. So just let him do that for a second. So what I'm going to do is guess which card he's chosen without seeing what it is. And I'm going to try and read his mind, see if I can get the information out of him and find out which card he's chosen. So is he getting on all right? Is he choosing a good card? Okay, so delete out which cards you've chosen. Delete what it says 1 row updated at the bottom. Yep, cool. You deleted it, so I can't see what you've got. All right. Okay, come on then. Okay, let me just roll that back. So the information is now gone. So I don't know what you've chosen at all, do I? Well. Okay, so what I'm going to try and do is just read your mind. So look at me. So you need to think about your card, think of it, and just keep thinking about it over and over. Just repeat it to yourself in your mind. Think over and over in your head. And okay, you've got it. You're clearly visualizing it. Yeah, come on, just and you've got it on the tip of your tongue. Just keep thinking about it, thinking about it. Yeah, yeah. Okay, okay. I think I'm starting to get it. I'm starting to get it a little bit. But okay, I'm not sure I can read it directly, but I'm going to pass it through down through my hands onto the computer. Okay. So okay, you ready? Okay. 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 Still with me? Yep. Keep thinking about it. Keep thinking about it. Keep thinking about it. Okay. Let's just scroll down and ready and okay, ready. Okay. Was that your card? Yes. Well done. Okay. Well, everyone, give Giannis a hand. Thank you. Take your. There you go. Take your seats. So hopefully you enjoyed that, and hopefully you'll find that was that your card. So what's going on here? What's going on? Well, again, I've used a little bit of a sleight of hand, and I've done something a bit strange here. So let's scroll down. We can see we've got 3 columns here. So I did a select star, and we've got value, suit, and name. But let's run the query again, this time with this little PK column. Run that. What do we find? Ah, there's an extra column there. Where did that come from? What's going on here? Well, this is a new feature in Oracle 12c. It's an invisible column. So you can mark a column as invisible. This means it doesn't appear when you issue select star, describe the table, do other kind of generic table access. So when Giannis picked his card and ran the update, I had, again, naughty me, I had a trigger on the table which updated this column in the background. So it set that primary key column in the background, which you couldn't see. So that's all very well and good, but how did I know it was going to end up at the top? How could I be sure of that? Any ideas? No? Yes, it's an index organized table. So an index organized table in Oracle is a table that is an index. So it's physically sorted in the same logical order that the primary key tells it. So the leading column of the primary key was this PK value, then these other ones. So by setting the primary key value to -1, it's going to be sorted, before all the other cards. So this means it kind of floats to the top of the deck, because this is, like I say, it's an index organized table, so the entries have to go in a specific location. They have to go in the correct location in the index as defined by the order. So, columns, these are ordered numerically, and then, as you can see, all these other ones are coming out in order because it's an index organized table. Now, just word of warning, I've set things up specifically so I know this would happen. Just because you've got an index organized table doesn't guarantee that you will always get them in the order of the table. I've just got it so everything fits in a block, and of course, when it reads a block, it's going to read the whole block in order. When your table's large, this isn't necessarily always going to be true. If you want your data ordered, make sure you use an ordered by. So again, being a little bit tricky here, but it works in this case. So everyone following that? Any questions on that so far, or? Yes. Well, okay. Let's have a look. So you can see, created the table and have this little procedure trick J, and that submits a job and commits it. So again, compound trigger on the table, collecting the values after each row, and after the statement's completed, calls the job that re-updates it afterwards. And actually, it's a word of warning here when you do non-transactional thing in triggers. So do something like send an email or set some package state or things like that. If you roll the statement back afterwards and you've done something non-transactional that commits separately, say in an autonomous transaction, that still happened. That is done. So just because you roll back your things, you can do stuff in a trigger which still happens. If you do something a bit crazy, like have a on-insert trigger which sends off emails to people every time a row is inserted, but of course some of them you might roll back, you can get people having emails for confirmations for things that don't exist, orders which never completed, or statuses which no longer exist. So be really careful when you do non-transactional things in triggers, because weird things can happen. Okay? Okay, so that was the second trick. We had invisible columns, so there was that hidden column you couldn't see, which controlled the order by an index organized table, so I knew I could get that row to flow to the top. I'm not going to tell you how I got the card to appear at the back, but I'm sure you'll figure that out yourself. Okay, so before we go on, I will just reset the database so there's nothing in it. Delete everything out of it. So to finish, I'm going to do something a bit special. This time, what I'm going to do is change the value in a row just by issuing a select statement. So I'm not going to run any inserts, I'm not going to run any updates, I'm not going to run any deletes. All I'm going to do is run a select, and the value of the query will change. Okay? So let me just create the table here, and off we go. So I've got a little one row, one column table with a little message in it. And as you can see, there's no other objects in the table. This is a table, unlike before where it was views. There's no triggers on it. Not that that should matter because I'm just running a select. And there is no other code in the database that refers to this table. But I'm still going to run a select statement, which is going to change the value returned by the query. Okay, so you ready for this? Just going to psych myself up a little bit. I need to warm up. It doesn't always work. So just, here we go. You all ready? You ready? Here we go. All right, ready. 3, 2, 1, and yeah! So change the value in a table just by issuing a select statement. That's pretty cool, isn't it? Okay, well, before I go on, I'll just update it back to what it was. And we'll just save that. We take a look at the table, and we find that, oh, I haven't updated it. Or at least, not what I expected it to. What's going on here? There is still no triggers on this table. So there really is nothing up my sleeve here. Honest? Well, no. So, I'm sure by now you've figured out it's not magic really. And what I've done is use another new feature of Oracle 12c. That's temporal validity. So if we pop over here, run the query again, we can see these magic hidden columns, magic start and magic end. And I'll use this flashback archive to set the valid time to current. And you'll see something a little bit interesting happen. There isn't one, nope, I meant to set it to all, sorry. Set it to all. There isn't one row in this table. There is, in fact, 3 rows in the table. What I did is to find a temporal period on the table. And using this flashback archive command, this automatically controls which rows in the table you can see. So Oracle's automatically generated extra predicates. It's created an extra where clause for you to control, so you can only see the rows where the start and end, or this current date is between the start and end values for the period. So if I just set that back to current for a second and run that again, so we can see, so there's just the one row at the moment. So when you set that to current using this flashback archive command, it adds a clause to check whether sysdate or systimestamp is between those start and end values. So it only shows the rows where that happens. So we can use that to see, and you can see here, so the start date was 1518, current timestamp 1520. I'm an hour ahead of, or an hour behind, 2 hours behind you guys. So, and the end date's some point tomorrow. So it only shows that row because these are the only ones between that time period. So we can use it to see all the rows, that's kind of the default behavior, or the currently active rows. But I also can use this as of option to see the rows that were given at a particular point in time in the past. So if I set that to 3 minutes ago, and hopefully I've timed this right, we find that it just goes back to the first row, the first row, the second row, because that's the one that was active 3 minutes ago. That's the one where the start and end period was around 3 minutes ago. Now, if you remember, you may not noticed, there were no rows in the table, but, the start date was 5 or more minutes ago, was more than 5 minutes ago. So if I set the interval to 5, run the query again, we find it returns nothing. There is nothing where the start date was more than 5 minutes ago. So again, you might be saying, well, again, kind of neat magic trick, but this is going to be a bit confusing. You know, you could do something like set a logon trigger to call this package so only currently active rows are visible, but that's a bit fiddly, isn't it? It's a bit magic. It's the kind of thing that slows people down when they start the new system, can really confuse people, and just increase on-ramp time. So this is kind of handy when you're doing ad hoc queries. You want all the queries to be at a particular time. But for your general application behavior, I wouldn't really recommend this. We just set it back to current before we go on. What you can do instead, and what I recommend you do instead, is use this as of period 4 syntax. So you do as of period 4, what your period is called, so in this case magic, and the timestamp you want it valid for. So if you just want the current timestamp, sys timestamp. In this case, I'm going to the trunk timestamp, so first thing this morning. Run that. Now, and we'll see we get no rows because there were no rows with a start date earlier than this morning. Now you can see I set that to current, so that the flashback archive to current. So in theory, it's only showing the currently active rows. The as of period 4 syntax overrides this behavior. So as of period 4 takes priority over whatever you've done with this DBMS flashback archive command. So again, some of you might be saying, well, that's kind of cool. Well, what would I want to use this for? Well, let's just set the currently active rows to true, to all of them. So a common use case is managing address histories, particularly if you run a business, or it's useful to know how your customers moved around. This is useful for reporting and intelligence purposes, so you can know when people move, do they change and buy different services for us, or do they leave and go away? And it's particularly important for utility companies, things like electricity, gas, your broadband, where the service is actually tied to your property, to where you live. It's really useful for a company to know where you lived at a point in time in the past, so you can get billing correct, you can deal with customer complaints correctly, and so on. And you can use this temporal validity to do that. So when I did it with the magic table, I just created the period. But in this case, we've got moved in and out row columns. Most cases, you probably don't want those invisible columns. You want real columns you can actually see, so you know what's going on. And you can use those too. So we've got moved in and moved out, defined our period, and stated which columns from the table make up that period. So if I create that table, now note, I could have left these blank, so I could have deleted those. In that case, Oracle would have created 2 new invisible columns called resident start and resident end. Anyway, I've got my table now. So I've been moving around a bit recently, started in the Shire, moved to Rivendell, and then finished up in Mordor. And so you can see we've got the 3 different rows in the table. Now, my magic providing company wants to know where I currently live. So if they've got like your customer management system details, you want to see where people currently live, then you can use this as of period 4 syntax resident today, find out where I currently live. Where am I? I moved at the end of last year. So I'm in Mordor. So you can use this to kind of simplify your queries. So again, you might be saying, well, why would I want to do this? Why would I do this rather than just writing out the where clause. So if we look at the execution plan, you can see when it comes up, Oracle's automatically generated the where clause for us. So why do that instead of just writing this all out yourself? So hopefully you can see, so it's got moved in date less than or equal to sys date, and moved date is null, moved out date is null or greater than sys date. Well, a couple of reasons. One is it's really easy to make a mistake writing these kind of where clauses. Did you mean greater than and less than or equal to, or just less than? Did you mean greater than or equal to, or greater than? It's really easy to make a mistake, and this is the kind of problem which is difficult to notice unless you do thorough testing. And the other problem is you ask 3 different developers to come up with a way for managing date histories. It's likely you'll end up with 3 different queries. So one might do it this way, the correct way, the way temporal validity does it, and like I say, the correct way in my opinion. Some other people will do it strictly less than. Other people will do greater than or equal to at both sides and do these crazy +1 type things. It's likely you'll end up with many different solutions. And unless you've got good governance, good control, making sure you're checking all the queries, different people might end up with different solutions which end up with subtly different bugs. So by using this as of period for syntax, you simplify your queries drastically. You take away a lot of thinking. They're all going to handle dates in the same way, which reduces your typing, reduces your thinking, reduces your testing, just makes your life an awful lot easier. So instead of going, well, which way around is it? Am I greater than or less than? Let me check some existing code, see which way the other developer did it, and so on. Just use this as of period for syntax, and it gives you the queries automatically. Like I say, we did it for sysdate. You can also do it for a date in the past. As in living in Rivendell, start of last year. And this is really cool. I really like this. Many of you will have databases and be thinking, well, can we really use this? So if you're on 11G or whatever, when you upgrade to 12C, you can just add the period to the table. So if you've already got tables with start and end dates, you can just alter table, add the period, say which columns they are, and you've got this for free, basically. So you don't need to necessarily reverse engineer your database, unless your data's screwy and you've chosen the wrong way of managing dates. So let's just put that back to current. So we can see, I'll just wrap up a bit. So we started off, cups and balls trick. We had views over tables, which enabled us to insert rows we couldn't query back out again. But by adding the with check option, we prevented that, or at least we got an exception. Use the trigger on the cups table to set the query rewrite integrity session parameter stale tolerated, so it could Oracle could substitute in that materialized view that had information that didn't match what was in the table itself. We did a kind of cool card trick where we had a trigger on a table. We set an invisible column, enabling it to rise to the top because it was an index organized table, and the values got sorted to the top. And we use temporal validity, a really great simplification feature for managing dates. You can do that with by setting the flashback archive session parameter. Again, like I say, something that's maybe useful if you want to do a magic trick or have ad hoc queries you all want to know be consistent for a point in time. But for your applications, I really wouldn't recommend it. I'd recommend you would go with this as of period for syntax. So I hope you enjoyed this. It's easy to forget when you're developing applications that technology is really cool. It's really powerful, and you can do some really funky, fun stuff. And it's easy to get lost in the day-to-day building stuff, deploying it, dealing with your manager and your colleagues, and so on. So I hope you've had a bit of fun here, and I hope you've enjoyed it. I'll ask for questions in a second. Feel free to ask, but there's only one thing I won't explain, and that is where all the bananas have come from. So I hope you enjoyed that, and questions, time for questions. Go on. I'll leave you to think about how I put the card on the desktop. Okay. So I have to keep some secrets. Magicians have to keep some secrets. So I won't tell you about how the bananas got there or how I got the card on the desktop. But anything else, go ahead. There's one back now.
I have two questions.
Yeah.
First one, in place if in this as of period you put their sys date or some constant date, can I put there some other tables column as well if I joining?
If you're joining a table, I don't know. I'd have to check. We could try. Why don't we try quickly? Let's see, because we can do. So you mean like join magic table as a period for. No, something tells me it won't work, but I've never tried, to be honest. So you mean like this, and then do moved in date, like that? You mean?
Yeah.
So let's give that a go. I'm pretty sure this is going to fall over in a heap. Yeah, missing expression. So no.
Okay. And the second about invisible columns, as they don't appear in when you're selecting star, they will they appear in a row type in PL/SQL?
I can't remember. I don't think they do. I can't remember off the top of my head. I'll have to check. I'd need to check that. Okay. Any other questions? Yeah, down in the front here.
About that query rewrite, can you set it permanently on a materialized view and not on the session level?
So it always does it stale tolerated for a
for some particular materialized view.
So the stale tolerated you can either set at the system level or at the session level. So you can't control whether it's stale for a particular materialized view. But what you can do, if we go back where I actually created the table, where is it set up? There we go, of the materialized view. You see this enable query rewrite? You can specify disable query rewrite for the materialized view. So you can set stale tolerated globally for your database and then disable whichever ones materialized views you don't want to be rewritten. So it's a bit of a backward way of doing it, but yeah, it works. Yeah. Any other questions? Got a couple of minutes left. Yes? No? No? Well, thank you all. If you've got any more questions, feel free to come up, and I hope you enjoyed this.